Hello, this is Dylan, and I want to talk to you about organization isolation in the context of the GitLab cells architecture. The GitLab cells architecture is a way for us to horizontally scale GitLab.com by decomposing it into many smaller cells, which are effectively self-contained GitLab instances that have their own Postgres database and other data stores, and only share a minimal amount of what we call cluster metadata down here, for example, the users, which will be able to log in and use any of the cells. And the reason organizations are part of this architecture is that organizations effectively provide an isolation context where we're able to move an organization from one cell to another cell seamlessly such that users using GitLab.com don't really notice or care which individual cell is holding their data. Now, the way this is possible is by ensuring that each organization doesn't contain any references to data outside of that organization. In this example, it's possible that an organization can contain many top-level groups, but those top-level groups are not going to be able to contain data that references any top-level group that happens to be in a different organization. And therefore, we can confidently say this organization can be moved to another cell without the user noticing anything's happened because there won't be any relationships that are now split across two different Postgres databases effectively. Now, this is why we need organizations to be isolated in order to implement the cells architecture. But we have many features in GitLab.com today, such as issue linking, which allows you to relate data that spans two different projects in two different groups without really any constraints. So here I can, for example, show I have a top-level group, GitLab.org, and another top-level group, Zook test group, and they both contain issues. And I can just relate those issues to each other. And this issue link here now effectively spans two top-level groups. And if these were in top-level organizations, then that would mean we had data that spanned two different top-level organizations. And if those top-level organizations were on different cells, which had their own databases, there'd be no way for us to really render this page easily because this page contains data that is needed to be fetched from different databases. This is why we need the isolation. Now, individually, it might seem that we could probably solve this specific problem by implementing, by putting this data in the shared cluster-wide metadata database, for example. Or we might be able to implement it through some more clever cross-cell replication or cross-cell communication in order to fetch this data. But really, this is just one simple example of many, many features in GitLab that allow users to do this. And ultimately, we won't really be able to meet our scaling objectives if all of these cells now all have data that spans across many different cells. So one example that makes this a bit clearer is group sharing. Now, group sharing is a functionality in GitLab where I can take the GitLab test group and I can invite the GitLab.org group to be a member of this GitLab Zook test group. Now, in this case, once I've done this, all members of the GitLab.org group are now also members of the Zook test group. That's how this feature works. Now, this is particularly problematic from a scaling perspective if we were to try to replicate that data across all cells, because group membership effectively allows sometimes thousands of users access to thousands of projects in another group, and it's often responsible for some of our slowest and worst scaling features in GitLab today. And we really need to get the horizontal scaling benefits by making sure features like this don't span organizations, so that in the context of a single organization, we don't need to fetch data across multiple databases, or we can have our databases generally be smaller. Now, just another example of a feature where we could also violate the organization constraint is epic relationships. And for example, I can take this GitLab.org epic and make it the parent epic for an epic inside the Zook test group. So I can add that as a parent epic here. And all of a sudden, that's now the parent epic there. And that conceptually won't make sense in the context of cells and organizations where potentially a lot of functionality in GitLab is derived from this hierarchy of epics, and they will again span multiple databases, and features just won't really work properly in cells if we allow that across organizations. So what I want to demonstrate today is how I've implemented this isolation locally. I've got some functionality in my GDK where I enforce these isolation constraints. So here is an example. I've got two issues. One of the issues is in group 1 in org 1, and the other issue is in group 2 in org 2. Now, we want to ensure that since these belong to different organizations, that we cannot link these issues. And that's what I've implemented here. We get an error when we try to link these. This is also something we can see here. It returns some specific error details to the front end, which we could potentially then translate into some UX so that the user understands why these things cannot be linked. This is modeled basically automatically right now in my POC here, where we are taking all of the foreign keys in the database, which basically model how all the data is related to each other, and basically adding a rule where any foreign key can't span two different organizations. So the reference on one side of the foreign key can't be in a different organization to the reference on the other side of the foreign key. This is a fairly robust approach because this happens when you write the data to the database, so we can be pretty confident that you'll never be able to insert invalid data like this. But it won't cover all of the relationships we have in the GitLab application because some of them don't have foreign keys and they're just modeled in the application as part of our Rails models. And in that case, we can probably extend this functionality as well to ensure that people can't insert related data across organizations in the same way. Now, just to, well, for this, you can see that the UX is not quite implemented yet. We have just an error message. But ideally, in all cases where we can accidentally link data between two different organizations, the ideal scenario would be that we didn't allow users to even select data and connect things that belong to two different organizations to begin with. Since we have a lot of functionality in GitLab like this, where we're allowed to copy and paste direct URL references, we don't have any way to really prevent the user from doing that ahead of time, so we need to present them with an error message. But the group links is a better example right now, and I haven't implemented this yet, but right now we allow you to select the select another group that's in a different organization and add that as a member to this group. But the logic I have on the back end is going to error out and not allow you to do that. But the preferred user experience here would be that all these kinds of drop downs with searches like this would just never present you data that belonged in a different organization to begin with. And that user experience actually has some other benefits that for other problems we're trying to solve today, where typically these entire instance-wide dropdowns like this don't work particularly well on GitLab.com or other large GitLab instances today because they tend to just show you a bunch of irrelevant data that you're not interested in, and searching across millions of groups like this is usually just not that great an experience. So when we start to build functionality that is scoping all of these dropdowns to a single organization, we expect that might provide better user experience anyway. And I also wanted to just demonstrate that with the implementation I have here, we don't actually prevent you from relating data that is in two different top-level namespaces, but where those top-level namespaces are in the same group. So, for example, I have here an issue that belongs to group 3 in organization 1. So this is a different top-level group, but it is in the same organization as group 1. So I should be able to, and I am, take this issue and add it as a link to an issue in group 1 in org 1. And that was already linked there from before, but I'll add it again. And that works. So the isolation we've implemented on the back end is not based on top-level groups, but indeed based on the organization. And this is important because we do need to support the use case where people bring multiple top-level groups into one organization. Now, this is the first part of organization isolation, but one of the problems this leads to is in order for people to be onboarded into using organizations where they already have existing top-level groups, we need to provide some way for us to detect whether or not it would be possible for them to move their top-level group into an organization without violating these constraints. So, and if we can validate that a top-level namespace contains no references outside of that top-level namespace, we can allow the user to move it into an organization. But if it did contain some references like issue links or group membership, group links, then we would want to be able to present that to the user and provide them some way to fix it before they could then move their top-level group into the organization. So that's what I want to demonstrate, what I've implemented next. And now that we have some data that spans multiple top-level groups, in this case, we have issue 1 related to issue 3. Issue 1 is in group 1 in org 1, and issue 3 is in group 3 in org 1. That's fine within these constraints, but if we wanted to move group 1 to a new organization, this would be a violation, and we need to prevent users from being able to do that. So in this, in my GDK, I have a implementation of how this might look as well. If we look at group 1 in org 1, we can go to the settings here, and we have here a list of the violations preventing us from moving this group to a new organization. And this is dynamically implemented, basically similar to how the original constraint is implemented, but in this case, it is going only up to the top level namespace and checking that all of the data related to this group and the projects in it and the issues within those and on and on and on downwards, ensuring that all of that data only references data that is in this top level group, so it should be safe to move this top level group. Now this is only half of the story because as this diagram shows, we need to support being able to move 2 top level groups into an organization. And so in theory, we should be able to have a way to say, I want to move group 1 in org 1 and group 3 in org 1 at the same time to a new organization. And then I want the isolation constraints to be verified in the context of those 2 top level groups. And in that case, we just need to expand this implementation a little bit to search and validate that it's all within some set of top level groups that the user is trying to move. We also need to expand this a little bit to provide something a little bit more actionable here. Obviously, we can provide links to the things that have these violations so that they can clean them up. And we expect this is quite important for adoption of organizations on GitLab.com because at present, all existing top-level namespaces on GitLab.com are part of the default organization. And some of those top-level namespaces are likely to contain just a few violations where they had small things like issue links that are outside of their top-level namespace that they just need to delete before they can move it to an organization. And we need this validation in place so that they can fix that. Now, these changes are likely needed before we can start adopting organizations because we need these constraints to be in place before we start moving organizations into different cells before we add a second cell on GitLab.com. If we didn't have these constraints in place, the functionality would work when we only have a single cell, so it would be fine to link two things here that are on a single cell. But then we would start collecting, a bunch of organizations on GitLab.com in our single cell that violate this constraint. And then when we did try to introduce a second cell on GitLab.com and we moved some organizations to it in order to reduce the size of our first cell, we would start to see a whole bunch of functionality that those users were using just disappears or breaks, or some of the UI doesn't render correctly because the linked issues doesn't work, or with group links, the permissions all of a sudden change. So we really need to fix that ahead of time before we can actually start rolling out organizations and therefore cells. This is why the concept is generally necessary and a prerequisite to users creating their first organization outside of the default organization on GitLab.com. And there are quite a few more improvements we'll need for this violation list functionality, as well as the other original constraint. For one, we need to move this to be some kind of background process as well, where the user requests that their namespace have the violations checked, so that, or declares that they are interested in moving to an organization, so that we can generate this list for them, because this is incredibly expensive to generate for large groups with millions of rows, so we can't just have it generated on the fly like that when they request it, but it'll need to be sent to a background process. We need to expand it to validate in the context of multiple groups for customers that have multiple top-level groups, including ourselves, where we have GitLab.org and GitLab.com, and we would want to move both of them. And yeah, we just need to expand the errors so that these are more actionable for users as well. And those are all the next steps on this organization isolation constraints. Thank you.